The lesson outcome for this video is I can use power rules. And we are going to learn just the first 3 power rules today. Alright, so first of all, some important vocabulary as we start working with powers. A power is one of these right here. 7 to the second power, or 7 squared, or raised to the second power. Alright, as you can see in red here, the exponent is the red term there, and the base is the blue term. So the base is the large number that looks, kind of regular, and then the 2 is the smaller number, and that's the exponent. Remember what 7 squared means? 7 squared means multiply 7, multiply 7 times itself twice. So 7 times itself twice, so two 7s. 7 times 7 is 49. So this power would evaluate to be 49, 7 squared. A couple other little things I want you to remember as we kind of start this unit. Remember that if a term like x to the third power has no number in the front of x, there is a number there, and that number is 1. Just remember that. Again, we've got a base of x and an exponent of 3 there. Another thing I want to remind you of is that every number or variable has an exponent. So here we've got a 5 and a y, 5 times y, 5y. Now y has an exponent of 1. If there's no 2 or 3 or 4, that means the exponent is 1. Okay, now that got a little bit messy here. But that's an exponent of 1. Do you know that 5, the coefficient, the number right here, also has an exponent of 1? So that's something to kind of keep in mind. What 5y typically or technically means is 5 to the first power times y to the first power. And that'll just be handy as we move along in this unit. So here is a list of the power rules we are going to learn in this unit. There are 7 of them. We are going to start today with just these first 3, and I'm going to talk about each of those on the next 3 screens. A key word, other than the word power that you see over and over here, we got power, 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 power. So we're dealing with powers, which is what we just showed on the previous page, a base and an exponent. But the other word that shows up a lot in today's lesson and rules is product. Remember that a product is a multiplication situation. All right, so let's look at those 3 rules. Okay, so let's take a look at the first 3 rules. Here's the first one. The first one is called a product of powers. Okay, and so like I spoke about on the previous couple screens, a power is the situation where we have a base and an exponent, and a product is multiplication. Okay, so we've got a power right here, a to the m power, and we have a power here, a to the n power, and we've got the product of them because it's multiplication. So here's the rule. Well, actually, let's kind of discover the rule. Let's discover the rule by doing this example right here. Okay? So as I mentioned on the previous screen, when something doesn't have an exponent, the exponent is 1. So we have 3 to the first power times 3 to the third power times 3 to the second power. So if you remember what exponents do, exponents say to multiply the base times itself that many times. So if we've got 3 to the first power, that means multiply 3 by itself once, so that's just 3. And then we've got multiply the base of 3 times itself 3 times, so that's 3 times 3 times 3. And then we've got the base of 3 multiplied by itself 2 times, which is 3 times 3. Now if you look, what we have now is we have 3 times 3 times 3 times 3 times 3 times 3. Well, that's the base of 3 being multiplied by itself 1, 2, 3, 4, 5, 6 times. So 3 raised to the 6th power. So here is the situation. If you look back at our exponents, okay, we had a 1 and a 3 and a 2. What do you get if you add those exponents? 1 plus 3 plus 2. Well, 1 plus 3 plus 2 is 6, which is what we ended up using right here, 3 to the 6th. So that is the rule. The rule says that if we have a base of a and a base of a, both raised to a power, we can keep that base of a and we can add the exponents. So we can take the first exponent and add it to the second exponent, and that will be a simplified answer. So again, 3 to the first times 3 to the third times 3 to the second would be, since they all have the same base of 3, 1 plus 3 is 4, plus 2 is 6, so 3 to the 6th power. Okay, so using the rule on this next one, okay, we know that x to the first power is right there. So we have two different bases. Okay, hopefully you can name them right now. One is x and the other one is y. Okay, those are the bases. So if I know I have a base of x and I have a base of y, I'm going to start by just multiplying x and y, and now I have to think about my exponents on those variables. So we have a 1 and a 3. What are we going to do with the exponents when we have the same base? We're going to add them, so we get 4. And then on y, we have 2, 5, and 4. 2 plus 5 is 7, plus 4 is 11, so we have y to the 11th. So x to the 4th, y to the 11th. Okay, now the second rule is called the power of powers. Power of powers, which means we've got a power situation right here. A to the m is a power situation, and we're raising that power to another power. Okay, so let's look at an example and see what the power of powers rule is going to look like. So we have 3 squared times 4. Okay, 3 squared times 4. What this means is that you're going to take this 3 squared and you're going to multiply it by itself 4 times. That is what an exponent does. So I'm going to take 3 squared and multiply it by itself. Multiply it by itself 4 times. So 3 squared times 3 squared times 3 squared times 3 squared. Now look at what we have. We have the power rule that we discussed on the previous screen. If we have a base of 3, base of 3, base of 3, base of 3, we can keep the base of 3 and add the exponents. 2 plus 2 plus 2 plus 2 is 8. So if this is our answer right here, 3 to the 8th power, take a look at what that probably means about our power of powers rule. How did we get that 8? Well, 2 times 4 is 8. So that is the power of powers rule. If we have a single base raised to 2 exponents, we can write the base, and then we can multiply the exponents. So let's try the second one. It's going to be pretty quick. We have a base of x raised to the 9th and then raised to the 3rd. We can keep the base of x and we can raise it to the 9 times 3, which is 27. And then that one is done. Okay, and then the last power rule that we're going to learn in this lesson is the power of a product. The power of a product. Now, this is different than the product of a power because what we've got here is we've got a product multiplication situation being raised to a power. Okay, so it's the power of a product, two things being multiplied. So let's investigate again what's going to happen by looking at this problem right here. So 4 times 2 to the 3rd power means multiply 4 times 2 by itself 3 times. So again, we're going to write 4 times 2 times 4 times 2 times 4 times 2. Now what you'll see here is we've got two different bases. We have a base of 4, so we can write that base. And we've got a base of 2, so we can write that base. Now, how many 4s do we have? We have 3, and if you remember, that means the exponent is 1 on each of these 4s. So we've got 1, 2, 3, because we add those exponents. So 4 to the 3rd power. And similarly, since we have a 1 on each of the 2's, the base of 2 has exponents of 1, 1, and 1, so 1 plus 1 plus 1 is 3. So we have 4 to the 3rd power times 2 to the 3rd power. So now if we look back up at our original problem, 4 times 2 to the 3rd, what we have is 4 to the 3rd times 2 to the 3rd. So we took this and we raised it to the 3rd, and we have this 2 and we raised it to the 3rd. So the rule is a times m raised to the n power is base of a raised to the m times base of b raised to the m. Okay, so if we look at the next example, we've got 9 times x raised to the 4th. So we need to take each piece that's being multiplied in the parentheses, each of those factors, and raise it to the 4th power. So 9 to the 4th power times x to the 4th power. Now, 9 to the 4th power is 6,561. 6,561. I used my calculator for that. And then x to the 4th. And this last one, we have 3 times x times y. This time we have 3 different things being multiplied together, product of 3 terms there. And so all of them need to be raised to the 3rd power. So even the 3 in the front, which sometimes people forget, 3 gets raised to the 2nd power, x gets raised to the 2nd power, and y gets raised to the 2nd power. 3 squared is 9, x squared, y squared. And those are our first 3 power rules.